Our story begins with a bang, the Big Bang, an event that marks the birth of our universe. Imagine a universe smaller than an atom, filled with unimaginable energy, a seething cauldron of potential. Then, in a fraction of a second, it explodes, unleashing a torrent of energy and matter. Space itself expands at an incredible rate, creating time and the laws of physics as we know them, setting the stage for everything to come. The universe is a hot, dense soup of energy and particles, a chaotic mix that will eventually form the building blocks of everything. As the universe cools, energy transforms into matter, giving birth to the first particles. Tiny particles clump together, forming the first atoms, mostly hydrogen and helium, the simplest and most abundant elements. These atoms drift through the vastness of space, pulled together by the force of gravity, slowly but surely. Over millions of years, gravity draws these atoms into massive clouds, the birthplaces of stars known as stellar nurseries. Within these clouds, gravity pulls hydrogen atoms together with incredible force, leading to the formation of new stars. The immense pressure ignites nuclear fusion, the process that powers stars and creates heavier elements. Our Sun, a rather ordinary star, is born from one such cloud of gas and dust, beginning its long journey. The remnants of this cloud, a swirling disk of debris, will eventually coalesce to form the planets, including our own Earth, setting the stage for life. Around our newborn Sun, the leftover dust and gas from its formation orbited in a vast disk. These tiny particles, remnants of the ancient stars, collided and stuck together, a process called accretion. Over millions of years, these particles grew like cosmic dust bunnies, forming larger and larger objects. These growing objects, called planetesimals, exerted their own gravitational pull, attracting more dust and gas. As they grew, their gravity intensified, pulling in even more material and accelerating their growth. In the chaotic dance of the early solar system, planetesimals collided, some shattering into pieces, others merging to form larger bodies. One of these growing planetesimals, destined to become our Earth, continued to attract more and more material, gradually increasing in size and mass. The energy from these frequent and violent collisions, along with the heat generated by the decay of radioactive elements within the Earth, caused the planet to melt, turning it into a molten sphere. This molten state allowed Earth to differentiate, separating into distinct layers based on density, with heavier elements sinking and lighter ones rising. The densest materials, primarily iron and nickel, sank towards the center, forming the Earth's core, a process that was crucial for the planet's development. Lighter materials, like silicate rocks, rose to the surface, eventually cooling and solidifying to form the Earth's crust, creating a solid outer layer. Between the core and the crust lay the mantle, a thick layer of hot, viscous rock that plays a vital role in the planet's geology. This differentiation is crucial for life as we know it, as it creates the conditions necessary for a stable environment. The churning molten iron in the Earth's outer core generates a magnetic field that protects us from harmful solar radiation, making life on Earth possible. The movement of the mantle drives plate tectonics responsible for shaping continents, creating mountains, and regulating the Earth's climate, which is essential for sustaining life. Early in Earth's history, a catastrophic event occurred that would forever shape our planet. A Mars-sized object, which scientists call Theia, collided with the young Earth in a colossal impact. This collision ejected massive amounts of debris into space, forming a ring of molten rock and dust around the Earth. Over time, this debris coalesced under its own gravity, eventually forming our Moon. The Moon's gravitational pull stabilized Earth's rotation and created the tides, influencing the rhythms of life on our planet. The impact also likely tilted Earth's axis, giving us our seasons. As Earth cooled, volcanic activity released gases from the planet's interior, forming the early atmosphere. This process was violent and dramatic, with massive eruptions and lava flows shaping the young planet's surface. This early atmosphere was very different from the one we breathe today, lacking oxygen and rich in greenhouse gases. It was a hostile environment with thick clouds and a hazy sky. Water vapor from volcanic outgassing and possibly from comets that bombarded the early Earth condensed to form the first oceans. These impacts brought not just water but also organic molecules essential for life. These early oceans played a crucial role in the emergence of life. They acted as a cradle, providing the necessary conditions for life to begin. They provided a stable environment for the first single-celled organisms to evolve and diversify. These microorganisms were the pioneers of life on Earth. Over billions of years, life transformed Earth's atmosphere, releasing oxygen through photosynthesis and paving the way for the evolution of more complex life forms, including us. This transformation was a slow but monumental process, changing the planet forever.